This is SpaceTime Series 28, Episode 11, for broadcast on the 24th of January 2025. Coming up on SpaceTime, signatures of ancient ice-free ponds and lakes found on Mars, discovery of a quasar that might have helped turn on the lights for the entire universe, and the European Space Agency's Probe 3 spacecraft quite literally splits in two. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered two sets of ancient wave ripples on Mars, which are signatures of long dried-up bodies of water preserved in the rock record. Wave ripples are small undulations in sandy shores of lake beds created as wind-driven water laps back and forth. The ripples were discovered by NASA's Mars Curiosity rover as it was exploring the red planet-scale crater. The two sets of ripples indicate the former presence of shallow water that was open to the Martian air and not covered by ice, as some Martian climate models have suggested. In fact, the ripples are one of the clearest indicators of an ancient standing body of water that can be provided by the geological record. Scientists estimate that the ripples were formed around 3.7 billion years ago. And that indicates that the Martian atmosphere and climate must have still been warm and dense enough back then to support liquid water in the open air. And that's an important timeline for our understanding of Martian history and when the red planet went from being a warm, wet world to the freeze-dried desert it's become today. The study's lead author, Claire Mondro from Caltech, says the shape of the ripples could only have been formed under water that was open to the atmosphere and acted upon by the wind. The authors created computer models of the ripples in order to try and determine the size of the lake that created them. The ripples are small, only about 6 millimeters high, and they're spaced 4 to 5 centimeters apart. Now, such small ripples in fine sand are formed by the actions of small waves, and this constraint limits the original setting to a shallow lake less than around 2 meters deep. Importantly, the timing of the ripples' formation around 3.7 billion years ago was a time in Martian history when scientists had assumed that the red planet was already becoming much drier. Mondro says extending the length of time that liquid water was present on Mars also extends the possibilities for microbial habitation much later into Martian history. One set of ripples, the so-called Prow outcrop, was discovered in a region that once contained wind-blown sand dunes. The other set, found nearby in the Ampare marker band of rock, suggests the presence of a lake up to 2 meters deep slightly later in Martian history than the Prow ripples. This is SpaceTime. Still to come, a quasar that might have helped turn on the lights of the universe, and the European Space Agency's Probe 3 spacecraft quite literally splits in two. All that and more still to come on SpaceTime. Astronomers have detected an intensely brightening and dimming quasar that may help explain how some objects in the early universe grew at a highly accelerated rate. As telescopes allow us to look further and further back in time, we're seeing large galaxies and massive black holes which are simply so big we can't explain how they could have formed so early in the history of the universe. And this new discovery, announced at the American Astronomical Society's annual meeting, is the most distant object ever detected by the NuSTAR X-ray space telescope. It's also one of the most highly variable quasars ever identified. The study's lead author, Leah Macro-Tully from Yale University, says the quasar is very likely to be a supermassive black hole with a jet pointed directly towards the Earth, and it's being seen as it looked in the first billion years of the universe's existence. Quasars are fascinating. They're among the oldest, brightest objects in the universe. As matter falls into a supermassive black hole, it initially forms an accretion disk around the black hole's event horizon. There, material is crushed and torn apart at the subatomic level, in the process releasing huge amounts of energy. Now, most of this material eventually falls beyond the event horizon and disappears forever into the supermassive black hole's singularity. But some of the energy and material escapes this fate, being transported along magnetic field lines and then shot deep into space in powerful jets, which we call quasars. These are so bright they can be detected from the other side of the universe. They shine right across the electromagnetic spectrum in radio, infrared, visible, ultraviolet, X-ray and gamma-ray wavelengths. In fact, this visibility has made quasars a helpful proxy for trying to understand the structure and evolution of the cosmos. For example, astronomers look to quasars to study the epoch of reionization. That's a period less than 1 billion years after the Big Bang, when the electrically neutral hydrogen atoms that filled the universe became charged in the process, producing the first generation of stars, which ionized the gas, making the universe transparent for the first time. This epoch of reionization is considered the end of the universe's dark ages. The precise timeline and source class responsible for reionization is still hotly debated, and actively accreting supermassive black holes are one proposed culprit. Now, for this study, the authors compared NuSTAR observations of a distant quasar designated as J1429 plus 5447 with unrelated observations 4 months earlier by the Chandra X-ray Space Telescope. And they found that the quasar's X-ray emissions had doubled in that very short space of time. Now, remember, we're talking here about relativistic effects, so 4 months on Earth corresponds to only about 2 weeks for the quasar. And this level of X-ray variability in such a short period of time, in terms of both intensity and rapidity, is extreme. It's almost certainly explained by a jet pointing directly towards the Earth, a cone in which particles are being transported up to 1 million light-years away from the central supermassive black hole's accretion disk which created them. And because these jets are moving at close to the speed of light, effects of Einstein's theory of special relativity come to play, speeding up and amplifying the variability. The findings, reported in the astrophysical journal Letters, are therefore offering crucial, much-needed new information for astronomers who are studying reionization. And it may also point astronomers towards other supermassive black hole candidates from the early universe. Macrotully says finding more supermassive black holes that are potentially hosting jets raises the question of just how these supermassive black holes grew so big in such a short timescale, and what connection that may have to jet-triggering mechanisms. This is SpaceTime. Still to come, the Probe 3 spacecraft splits in two, and later in the science report, discovery of a blood vessel fingerprint in the back of your eye, which could tell doctors whether or not you're at risk of a stroke. All that and more still to come on SpaceTime. A crucial step in the European Space Agency's eclipse-making Probe 3 mission has been successfully completed, with the spacecraft separating into 2 vehicles. The Probe 3 spacecraft has been flying jointly since last month's launch aboard an Indian Space Research Organisation 4-stage PSLV-XL rocket from the Satish Dhawan Space Centre in Sriharikota on the Bay of Bengal coast. The vehicle's deployment into 2 separate spacecraft leaves them ready to begin their cosmic dance in the world's first ever precision formation flying space mission. ESA mission managers in Belgium undertook the initial in-orbit commissioning during this stage of the mission using 4 ground station antennas in Australia, Chile and Spain. The 2 spacecraft successfully separated from each other while flying some 60,000 kilometres above the Earth, travelling at a speed of more than 1 kilometre per second. The 2 platforms will now drift up to 50 kilometres apart from each other, but over the coming week, mission managers will determine their relative positions, then use their propulsion systems to stop this drift and bring them back into a stable Ceph configuration. In their most precise formation flying, scheduled to be achieved initially in about 2 months' time, the 2 Probe 3 spacecraft will be flying just 150 metres apart and will need to maintain their relative positions down to a single millimetre for up to 6 hours at a time. This dance will be maintained by a sophisticated set of propulsion and navigation systems, working together using onboard autonomy. The mission will demonstrate this level of precision by creating an artificial solar eclipse in orbit. The so-called occulter satellite will cast a shadow onto the main optical instrument of the chronograph satellite, thereby allowing it to study the Sun's elusive outer atmosphere corona. Multiple sensors, including a laser-based system, will ensure that the shadow, just 8 centimetres across, created by the occulting disk, will remain on the sensitive chronograph instrument positioned 150 metres away. In this precise configuration, the 2 satellites will be mimicking a single, much larger spacecraft. This report from ESA TV.
Prober, from the Latin for let's try, is ESA's family of experimental small satellites. Over the last 2 decades, probe missions have pushed forward spaceflight technology while gathering valuable science data. The next in the series, Probe 3, is the most ambitious yet. 2 satellites will fly together as one with millimeter-level control of their positions within a precise formation. In the process, one will eclipse or block the Sun for the other, to reveal our star's faint surrounding coronal atmosphere for scientific observation. Probe 3 requires a unique orbit. The satellite's orbit is highly elliptical, taking them to a maximum of 60,000 kilometers from Earth. Gravitational, magnetic and atmospheric perturbations are much lower this far out. This will make possible the precise positioning needed for formation flying and observing the Sun's corona. At this stage, it is important that the Probe 3 satellites perform a series of maneuvers to position themselves in relatively safe orbits with respect to each other. Achieving this nullifies any risk of the pair either drifting away from each other or colliding. After all commissioning checks are complete, the pair will be ready for their first flight in precise formation. The separation between spacecraft will be as short as 25 meters and as long as 250 meters, with a nominal separation of around 150 meters. The pair will determine their relative positions using a suite of metrologies, including radio links, satellite navigation, and the visual-based system with optical tracking of blinking lights. Once sufficient accuracy has been achieved, the final step will be to deploy the most precise measuring system of all, the laser metrology system, known as the fine lateral and longitudinal sensor. With this laser link, the total 3-dimensional formation can attain millimeter-level control. At this point, the occulter, with its 1.4-meter diameter occulting disk, which will observe the Sun in eclipse, lined up with the Sun, will cast a perfect shadow for sustained observation of the Sun's otherwise invisible corona. Once the occulter's shadow is maintained in just the right spot on the face of the other satellite, it will be safe for the coronagraph to open its protective door and start scientific observations of the Sun's corona. Solar scientists travel the world to glimpse brief solar eclipses, but Probe 3 will create eclipses on demand.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Doctors have found that blood vessel fingerprints in the back of the eye could help tell if you're at risk of a stroke. The authors looked into the complex network of blood vessels in the retina, with some features of this network already linked to stroke risk. Using artificial intelligence, the researchers analysed retina images from nearly 70,000 UK biobank study participants, 749 of which wound up having a stroke during the study's monitoring period. A report in the journal Heart found the algorithm identified 29 new features of the retina associated with stroke risk. Scientists say current ways of measuring stroke risk, such as blood tests, can be invasive, expensive, and inaccurate in some contexts. And using the retina, which can be imaged, could be a practical alternative. A new study claims species of early humans likely learned to live in desert-like conditions at least 1.2 million years ago. The findings, reported in the journal Communications, Earth and Environment, contradicts a previous belief that only Homo sapiens learned to adapt to extreme environments. Looking at archaeological data from Tanzania, scientists found evidence that groups of Homo erectus, a now extinct species of early human, were living there at a time when the area was under semi-desert conditions. The researchers say that data suggest that these groups were repeatedly returning to locations that likely had fresh water in the form of ponds, and they developed specialized stone tools that would have made butchery easier. They say this shows that Homo erectus were likely more capable of adapting to their environment than previously thought, which likely also helped them move into arid regions of Africa and Eurasia. A new study has confirmed that global extremes in 2024 have wreaked havoc with global water cycles. The study by the Australian National University found that 2024 was another year of record-breaking temperatures, driving global water cycles to new climate extremes and contributing to ferocious floods and crippling droughts. The 2024 Global Water Monitoring Report found rising temperatures are changing the way water moves around the planet, in the process wreaking havoc on water cycles. A new study has found that Paleolithic humans probably never heard of the paleo diet. This trendy diet is supposedly based on all sorts of foods your prehistoric ancestors would have eaten before the development of agriculture and industry 12,000 years ago. But new research examining the eating habits of early humans suggests that the so-called paleo diet might not have been an accurate representation of what ancient hunter-gatherers actually ate. The study, reported in the Journal of Proceedings of the National Academy of Sciences, indicates that man's Paleolithic ancestors enjoyed carbs. Tim Mendham from Australian Skeptics says the research is based on archaeological finds at a dig site on the banks of the River Jordan in northern Israel.
Your Australian listeners will know Pete Evans, or Pete Paleo Evans, he's promoting a lot of different things. He was a celebrity chef who got into the New Age movement. He was promoting the paleo diet, which has been around for a few years, which is basically saying stick with your fruit and veg, lean animal protein, nuts and seeds, and
What's
avoid...
wrong with that?
Nothing wrong with that. Nothing wrong with that. But it also ignore or don't include grains and legumes and dairy. Dairy might have been hard for Paleolithic people anyway, so it was hard to collect. But the whole thing was, it was supposed to be because this was the way Stone Age people maintained their health. Now, suggesting Stone Age people didn't live as long as we do, certainly didn't have the health care, and we certainly had a lot more predators out there who might sort of shorten their lifespan. But the question is, was this diet real? And the answer is no. It doesn't seem to be. There's been studies of sites of ancient people suggesting that there's grain products found in places where it's being ground up, the grains being ground up on tools and that sort of stuff, 780,000 years ago, which is well before modern humans, before civilization even. The suggestion, therefore, that people were eating grains which are readily collected. If you've got wild rice and wild oats and that sort of stuff. Legumes, the image of this paleo diet is portrayed in a certain way to make you healthier. Some aspects of it are, but the bits they say you should not do is not necessarily paleo. But every diet is a bit faddish. They come and they go, and someone suggests leaving out a certain thing and concentrating on something else. You have to take every diet that's portrayed to you with a grain of salt.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.